All right, 2.1 homework. Number 1, Terry is skiing down a steep hill with an elevation E of t. And this is his elevation after t seconds. So this is time in seconds, and this is elevation in feet. And they say that the equation is 3,000 minus 70t. Write a complete sentence describing his starting elevation and its change over time. So I would say that Terry had an initial elevation or starting elevation of 3,000 feet and went down 70 feet every second. That would be number 1, and then we look at number 5. Number 5, it says a boat is 100 miles away from the marina. So here is our boat, and here's the marina, and it says that it is 100 miles away from the marina, sailing directly toward it at 10 miles an hour. Write an equation for the distance of the boat to the marina after 10 hours. So D is its distance. So that's our distance, and it's in miles. And this is our time, and it's in hours. And so our distance is going to be 100 miles. And then every hour that distance gets shorter, so I'm going to take away 10 miles every hour. So that would be our equation. That's number 5. Number 17, it wants us to tell whether the function is increasing or decreasing. So if we look at number 17, it says that a of t is equal to 5 minus 2x. I could write that as negative 2x plus 5. I see that m is negative, so function is decreasing because I have a negative slope. I'm decreasing at a rate of -2 for every 1 that I run. So for every 1 unit in the x direction, I go down 2 units in the y direction. So that's number 17. Then I look at 21. So for 21, our equation is j of x is equal to 1/2 of x minus 3. So now, since, again, m is positive here because it's 1/2, it's positive, so our function is increasing. All right, that's 21. Let's look at 31. 31 wants us to know, find a linear equation if possible. So for 31, it says f of -1 is equal to 4, and f of 5 is equal to 1. That means for an x of -1, I have a y of 4, and for an x of 5, I have a y of 1. So that's my x1, y1, and my x2, y2. So if you tell me to find a line, I do y minus y1 is equal to m x minus x1. That is the equation of a line. So I can plug in for y1. So it looks like y1 is going to turn out to be 4. And it looks like x1 is going to turn out to be -1. So if you take x minus a -1, that's going to end up being plus. So I guess the only thing I need to do now is to find our slope. But the slope is y2 minus y1 over x2 minus x1. And so in this case, it's going to be 1 minus 4 over 5 minus a -1. It's going to be -3 over 6, or -1/2. Thus, y minus 4 is equal to -1/2 x plus 1, because I plug in for my slope here. So that's our linear equation. We probably would like it to be in a nicer form, so we distribute through a -1/2. Right? Let me take this and this, this and this, over just a little bit. This, I'm going to push over. Just going to move over. Oh, dude, come on, man. Just move over. Whatever. I'll do it this way. Okay. So over here, I have y minus 4. So I'm going to add that 4 over here. But 4 is the same as 8/2, right? And so I get -1/2 x plus 7/2. And that would be the equation of my line. If I did not tell you to put it into slope-intercept form, this would have been okay. But maybe that just looks a little bit nicer. So that's number 31. 35 is the same sort of deal, except now I've got this point. Oh, poop. Okay, so 35 is -2/8, and it's 4/6. So I'm going to very carefully label my x1, y1, and my x2, y2. And so since they want the equation of a line, I write it down. I plug in my y1 and my x1. So in this case, y1 is 8, and x1 is -2, so it ends up being a positive. So now I need to find m, but that's y2 minus y1 over x2 minus x1. So that's 6 minus 8 over 4 minus a -2. So it's -2 over 6, which is -1/3. Thus, we have y minus 8 is equal to -1/3 x plus 2. If I distribute, I get -1/3 of an x minus 2/3. And then if you add that 8, it comes over here. So you have -1/3 of an x minus 2/3 plus 24/3, because I multiply this by a well-chosen 1 of 3 over 3. So I guess at the end you get -1/3 of an x plus 22 over 3. Again, if I do not tell you to put it into slope-intercept form, what's in blue would have been okay. So that's 35. If I look at 43, 43 is just telling us to look at a graph and write the equation for what you see. Well, when we look together at 43, it looks like that. So I'm going to use that photo. I'm going to crop. Poop. Hit the wrong thing. Crop. Okay. So if this is what 43 looks like, wait, no, that's not 43, is it? We're not going to make that mistake for the 100th times. So 43 is above it. That was close. So there's 43. Okay. So there's 43. So if that's 43, then I guess I could use either form. Here, I think the mx plus b is going to be helpful because that is your y-intercept and that's your slope. And I think you can see pretty quickly that the y-intercept is +3 and the slope, I guess you go down 3. Ooh, let's see. I want it to be a nice number. So how about I go down 4 for every run of 2. So my slope is -4 over 2 or -2, right? I guess another way I could have done that, if I looked a little more carefully, is you go down 2 and run 1. So my slope is -2 over 1 or -2. So this is -2x plus 3, and that is the equation of the line. So that's 43. If we look at 45, 45 is an interesting question because it's a nice constant function. Crop, boom, boom, boom. So for this one, It's just a horizontal line, so it's simply y equals 3. If you want to be really slick about it, it goes through an intercept of 3, and its slope, its change in y, is 0. And so that's why it's y is equal to 3. So we have for 45. Then when you look at 63, this one's cute. So when you look at 63, it says find the value of a linear equation that goes through the point and has the following slope. So let me crop. So here is 63. So I want to have the slope of 3. Well, if this is equal to y2 minus y1 over x2 minus x1, right? If my slope is equal to 3, I'm going to say that these are 2 points. So I'm going to call this my x1, y1, and my x2, y2, and I can simply plug them in. So I have 6 minus 2 over, well, x2 is negative 4 minus x. And so now here's an equation with only one unknown in it. So to solve, I guess I can multiply both sides by negative 4 minus x. So these cancel. And on top, 6 minus 2 is just 4. And over here I have this times a 3. So if I want to, I can distribute. So we get negative 12 minus 3x is equal to 4. You could have also divided, but this is going to help you in the long run. If you add 12, you get 16. If you divide, you get negative 16 over 3. So that means x must have been negative 16 over 3 for everything to work out nicely. At the end, number 73, it says a town's population in 1960 was 287,500, and in 1989 the population was 275,900. Compute the rate of growth and make a statement. Well, the rate of growth would be the slope. So it's going to be my y2 minus y1 over x2 minus x1. So I'm going to call this x1, y1, and I'm going to call this my x2, y2. So the change in population would be 275,900 minus 287,500. And then the change in years is 1989 minus 1960. So in the bottom, 89 minus 60 is going to be 29 years. And then if you take 275,900 people minus 287,500, you find out that we had a decrease of 11,600. So if I take 11,600 and divide it by 29, you get exactly negative 400. And so that would be, I'm almost done. I'm just finishing this question. You can come in. So the units should be, that's people, right? Statement about the population rate per year. So that's people per every 1 year. So town is losing on average negative 400 people every year. 400 people per year. And that's it. Have a great one.